Hey guys, and welcome to the next tutorial of ethical hacking and penetration testing via Kali Linux. So in today's tutorial we will be learning about payloads. In the previous tutorial I have taught you about Metasploit, Meterpreter and the exploits. So if you have not gone through that, then I would recommend you going through all of those tutorials, because else you will not understand what exactly payload is. So a payload in Metasploit refers to an exploit module. So there are different types of payload modules in Metasploit framework, such as singles, stagers and stages. These different types allow for a great deal of versatility, and it can be useful across numerous types of scenarios. Whether or not a payload is stage, it is represented by / in the payload name. So for example, let me just show you. I'll just go ahead and open the MSF console. And while the time it opens, I'll show you how exactly a payload would look like. So if I wanted a Windows, let's say bind TCP payload, then I'll just go ahead and use Windows/bind_TCP, something like that. It's a single payload with no stage, whereas Windows consists of a stager and a stage. So it might be a bit confusing to understand. So bind TCP is the stager, and if you want to go ahead and check the stage, then I can just go ahead and type shell_bind TCP. So shell over here is the stage, whereas bind TCP is the stager. So three things that I would be covering today in detail will be the singles, the stagers and the stages. So we have our MSF console open. So singles are payloads that are self-contained and they're completely standalone. A single payload can be used, or it can be something as simple as a user, or adding a user to the target system, or running a calculator.exe file. After that we have stagers, and stagers set up a network connection between the attacker and the victim and are designed to be small and reliable. It is difficult to always do both of these well, so the result is multiple similar stagers. Metasploit will use the best one when it can, and fall back to a less preferred one when it's not necessary, or when it's necessary. So Windows NX or NT version versus the no NX stager, they contain nothing. Reliability issues for the NX CPUs and DEP NX stagers are bigger. It's a virtual allocation, and default for now is NX plus Windows 7 compatible, so you don't need to worry about that. After that we have stages. So stages are payload components that are downloaded by stagers modules. The various payload stages provide advanced features with no size limit, such as Meterpreter, or let's say VNC injection, or even the iPhone iPon shell. Payload stages automatically use middle stagers. A single receive fail with large payloads. The single stager receives, or you can say as a single receive fails with large payloads. The stager receives the middle stager, and the middle stager then performs a full download, and it will go ahead and read, write, and it can perform any kind of those tasks. So expanding on payload types in Metasploits. So I have briefly covered three main types, that is singles, stagers and stages. Metasploit contains many different types of payloads, each serving a unique role within the framework. So let's take a brief look at the various types of payloads available and get an idea of when each type should be used exactly. So let's start with the non-staged inline module. A single payload containing the exploit and full shell code for the selected task. Inline payloads are by design, you can say as it's by design more stable than their counterparts, because they contain everything all in one. So however, some exploits will not support the resulting size of these payloads, but still some will. So these are how the inline non-staged look like. After that we have the stager payloads, which work in conjunction with the stage payloads in order to perform a specific task. A stager establishes a communication channel between the attacker and the victim, and reads in a stage payload to execute on the remote host Meterpreter. And Meterpreter is the short form of Meta Interpreter, which is an advanced multifaceted payload that operates via DLL injection. The Meterpreter resides completely in the memory of the remote host and leaves no traces on the hard drive, making it exceptionally difficult to detect with conventional forensic techniques. Scripts and plugins can be loaded and unloaded dynamically as required, and Meter development is very strong and constantly evolving. So whenever you go ahead and try to run some kind of payload on your system and you execute a meter into their shell, you don't need to worry about, because normally no one will actually be able to gather any kind of information whether you actually went ahead and gathered any kind of information or you actually hacked into that, because there are no traces left on the hard drive. It only works on the memory or the virtual memory, and you don't even need to worry about the RAM, cleaning the RAM, because it's not that hard after all. But still, there are chances that some people may try to find you out if they are checking that. But still, if they're checking what are the things that are actually consuming RAM. But still, that's again a totally different story, because payload or the meter does not eat any kind of resources. It's a simple PowerShell or a command prompt kind of thing, which will hardly use like a few kilobytes. So you don't need to worry about any of these things, because normally any kind of application, if that's running, it will take probably a few MB, like 6-7 MB, or up to more than even 100 MB. So you don't need to. So people will not actually go ahead and be able to understand it until and unless the person is actually far smart. After that, we have the PassiveX payload. So PassiveX is a payload that can help in circumventing restrictive outbound firewalls. It does this by using the ActiveX control to create a hidden instance of the Internet Explorer, and using the new ActiveX control, it will communicate with the attacker via HTTP request and responses. So I'll just go ahead and explain this to you in detail. Let's say, for example, you have a firewall inbuilt, but somehow the person has gotten into your computer, but after he has sent you the exploit successfully passed on through your computer, but it is not able to go ahead and reach out, or it is not able to create a backend connection through the meter to our own Kali Linux. So what the PassiveX will do is that it will create a fake Internet Explorer type of let's say networking prompt, and I'll just show you how exactly looks like. I'll just go ahead in the task manager, and I'll just go to the process. Okay, it won't take me. Okay, so this is how it will look like. So the firewall will probably think that it'll probably think that okay, it's not a big deal because Internet Explorer is trying to gain access. So it will look something like it's actually something from the Internet Explorer that is trying to gain access, and the firewall will actually allow it. The reason being that it's going from inside to outside and not actually going to some random connection from some random application. So that's how strong it is. So after that, we have the NoNX module. So the NoNX is a short form for no execute bit, and it is a feature built into some CPUs to prevent code from executing into certain areas of memories. In Windows, NX is implemented as DEP, that is Data Execution Prevention, and the Metasploit NoNX payloads are designed to circumvent the DEP. So it's not a big deal to go ahead and bypass that as well. After NoNX, now you know what NoNX is. We have the ORD, that's Ordinal Payloads, and Ordinal Payloads are Windows Stager. They are they're Windows Stager based payloads which have distinct advantages and disadvantages. The advantages being such as it works on every flavor and language of Windows, such as XP, Windows NT, Windows 98, Windows 2000. It doesn't matter which until unless it is Windows and it works on DOS. And without the explicit definition of a return address. So they are extremely very tiny. However, two very specific disadvantages of ordinal payloads make them not the difficult choice. The first thing that it relies on is the fact that WS2_32 period DLL is loaded into the process, and it is being exploited before exploitation, which is not exactly happens every time. And the second thing being that it's a bit less stable than the other stages. So that's quite not a good thing for us hackers to go ahead and execute those kind of payload. But it works in every kind of thing in all types of Windows. So until unless you have these two things running, it won't matter. So after that, we have the IPv6 payloads, and the Metasploit IPv6 payloads, as the name indicates, are built into the function over IPv6 networks. So not much to know about all of these things, But these are the basics that you should know before going ahead and actually start using the payloads, because they can be quite harmful not only to the person whom you're trying to attack, but can be you, even if you're trying to go ahead and do some kind of mischief as well. So that would be it for this tutorial. In the next tutorial, I'll be continuing with the reflective DLL injection and generating a payload for Metasploit.